So today we are going to discuss a very important topic. Last session we have seen what are the different stages in a big data Hadoop project, and we have seen what are the how we are going to migrate from different source system whenever we're going to migrate into a Hadoop application. So we came to understand one thing. Until unless the data is not available in our HDFS file system, we are not able to process any data. So the concept of data locality come into picture. That means to process any data in HDFS or any Hadoop framework, we must send the data or push the data into the HDFS file system first of all. Then by using any processing tool like Peak, Hive or MapReduce and so on, we can implement to process those data. That means the logic will move near to the data where it is stored in the HDFS file system. So today we are going to see a very important discussion, the difference between LFS, DFS, HDFS. Okay. Well, LFS stands for local file system. DFS stands for distributed file system. HDFS stands for Hadoop distributed file system. Okay. These are the three different kind of file system we have. So we can discuss. We are going to discuss these three. What are the different file system are there? What is the difference between the three? Okay. So these are the file system we are going to see, and what are the difference between the three different file system. Okay. So first of all, LFS, local file system. What are the advantages and disadvantages of local file system? Local file system means, let me take a help of pen. Let me draw a diagram. In the same computer, I have like C drive, okay, D drive, E drive, F drive, and so on, based on the partition, number of partition. So what are the advantage of local file system? Any idea? This file, let me say you, my PC. In my let me go to my desktop. Okay, you'll see here how many partition I have done. Only 2 partition. This is my local file system. In the D drive, I put all my materials and all the audio, video, images, whatever I am all the personal stuff I am put in this local drive D. Whereas in C, it contains the OS related file along with other application related file. Okay. So these are all local to me. That means I am the owner of this file system. I am the nobody can access this file system until unless I give a specific uh, privilege to another person who can able to connect remotely to my system and access my file. This is my local system, right? So in the local system, until unless I don't want to provide any authentication or until unless I'm not going to provide any access to a remote machine, they are not going to see any content in my file system. Whatever I have stored, whatever I have done, everything. So what is the advantage of local file system? Any idea?
Privacy, security.
Yeah, correct. 100%. We can in the local system we can provide better security to our files and folder in a local file system. This is the first advantage. Any other? Any other? Suppose I want to do a copy, only small file, then I can retrieve it properly, right? If I want to any images,
Yes, yes.
right,
Yeah.
I can easily access, right?
Easy accessibility. Huh.
So the second advantage is I can able to or we can able to retrieve limited amount of data very fastly. Okay. Any other? So these are the two advantages. First of all, we can provide better security. The second one, we can able to retrieve the small amount of data very fastly. These are the two different advantages. Then, what are the disadvantages of local file system? First one, as I have told you, we can able to retrieve a small amount of data rapidly, but whenever we are dealing with a huge volume data, it takes much amount of time, right? So, data retrieval is bit costly when we are dealing with a little huge amount of data set. Okay. Suppose you are going to copy almost suppose 2 to 5 GB of data into your pen drive, then definitely it will take much time, right? But whenever you are going to copy around 500 KB or some up to some MB, then we can retrieve it very fastly. So this is the wherever one side the retrieval is sometimes it is very faster in case of low data set, wherever it is very costly operation or the retrieval process is become a very costly operation whenever especially we are going to deal with a huge amount of data. Okay. The next is any other? We can store store a limited amount of data. That is the size of data can store the size of data up to the hard disk capacity. Correct? If you are using your laptop with 500 TB or 512 TB, sorry 512 GB, then you can store up to 512 GB, not more than that. If you are using 1 TB, then you can up to 1 TB. But beyond that, it's very difficult. Correct? Up to 1 TB you can manage very well, and this is a disadvantage. The next one is we cannot perform distributed and parallel processing. That means at the same time I cannot process this data in multiple node because I'm in the same machine I'm doing the everything, right? So distributed and parallel processing I cannot able to achieve because at the same time I can multi-processing is different and parallel processing is different. Keep in mind. You will say that I can able to see audio, video at the same time I am listening the music and doing some audit. At the same time I am doing whenever I am watching the movie, I am at the same time I am trying open another tab in web browser and checking some. I am doing some shopping in the Amazon. So that is a multitasking. At the same time you are multitasking, but you cannot achieve parallel processing. Keep in mind, parallel processing and distributed processing is something different. Okay, distributed processing you cannot achieve in a single node. Single node means this laptop that I am using, it is single node only. Okay, it is never ever a multiple node we can consider. So in the same laptop, you will try to do distributed. How can I achieve distributed environment? That is not possible. Distributed and parallel processing only we can able to achieve whenever you are dealing with a cluster. Whenever there is a multiple node will be joined together in a cluster, and we are going to access the data. At the same time, we are going to get the we are able to achieve distributed and parallel processing. Okay. Then what is in the local file system? It is not possible. And one more thing, we don't have failover or backup mechanism in our LFS. Okay. Backup mechanism means suppose if your system got crashed, then it cannot able to recover the same data. Okay, it's cannot able to recover the same data. Okay, there is no backup mechanism. No doubt, you might able to keep the data, same sets of data in the multiple number of files. You can replicate the same file in a multiple number of folder, but it will be available in the same system only. If the system is crashed or system fail will occur, then you lost your data. So there is no backup mechanism. Okay. Right now, hope all of you understand this LFS. Correct? So,
Yes.
any doubt on this?
Oh.
Hello? Okay, fine. Then what is DFS? DFS stands for basically distributed file system. Okay. So what are the different advantages of distributed file system? We are going to see. First of all, to make you understand distributed, what is distributed, just to showcase you, let me take a help of diagram. Let's say these are the different nodes. Okay. So let's say it is a master node. Okay. Let's say it will be in the Bangalore location. Then another node is there. Suppose S1, HRD, then next is S2. It is Delhi location. The next one supposed to be let's in Mumbai location. Okay. These are the different nodes are there. And all these three nodes are connected to a one dedicated and common network. That means all these S1, S1, S2 and S3. All three are connected to a dedicated network. That means all these nodes are one or clustered node. Correct? This is a clustered node, this is a clustered node, and this one is also a clustered node. And this is nothing but the master node. Okay. So in a typical DFS system or distributed file system, what happens? There are multiple nodes. Instead of single machine, we have multiple machine. Okay. Where we can store the data. Here also I can store the data. Here also I can store the data. In this node also I can store the data. That means instead of storing all the data in a single machine, we are going to store in multiple machines. This is called distributed. Means the same data I can keep in multiple node. Okay. So what is the advantage in this kind of file structure? Whenever we are going to store the data in a multiple machine, okay, then what are the different kind of advantage we have? Let's see. The first hand, we can store, no doubt, as compared to LFS, we can store a huge amount of data, right? as compared to LFS, we can store huge amount of data, because we are going to store not only in a single machine. Suppose this we have a 500 GB. Okay, let's say I have a 500 GB data set. I want to store. I can store 500. I divide the 500 GB into 3 nodes, and I will divide. Suppose here I am storing 200 GB. Another one I am storing another 200. Another node I am storing 100 GB. That is possible. And let's say each node capacity is 1 TB. Then how much data I can able to store? Almost 3 TB. In future, another 1 TB of data set I need to store. Then what should I do? I will extend one more node. Store the another or 1 or 2 more nodes, and I can able to store the data in a distributed environment. That means I can able to store huge amount of data not only in a single machine but also in multiple machine. If required, if there is any growth in the data size, or as and when data size will be increases, at the same time I can able to extend my another node. I can able to store the data as well, right? What do you mean by this? That means it will provide you a horizontal scalability. This is called horizontal scalability. As the demand increases, supply will take the place. That means as and when there is an increase in the data size, we are able to accommodate the data size into a different node. Just we need some downtime. Okay, to add another 2 node or 3 node, or as per our requirement, we need some downtime, so that we shut down entire cluster and add another 2 or 3 nodes as per our requirement, and we can restart the cluster, and then we are going to store the data. This is called distributed environment. At the same time, what happens, as the data are stored in a multiple, instead of single machine, it is going to store in a multiple node. We can able to process at the same time from multiple nodes, right? But in distributed environment, there is a drawback is there. Either you can achieve the distributed processing, or else we can able to achieve the parallel processing. What do you mean by that? We are going to understand that one slowly. Let's see. First of all, as compared to LFS, we can able to store huge amount of data, but not unlimited. In mind, we can no doubt we can able to store huge amount of data as compared to LFS, but not unlimited. As and when the data size increases, we can add another 2 or 3 nodes according to our requirement, and we can accommodate that volumes of data in our cluster. Right? Then next advantage, we can achieve distributed or parallel processing. Achieve either distributed or parallel processing, but not both. Okay, what do you mean by this? as let's say I have a 10 GB file, okay, and I want to distribute this 10 GB file into, here I have kept 2 GB, another 2 GB here, another, suppose let's say 4 GB, and another 2 GB here, okay. But no doubt my data is got distributed into multiple node. But whenever I am going to perform any parallel processing, what happened? As this 10 GB, there is a dependency from one data to another data. Whenever I am going to start the processing will be always start from the first node where it is going to the initial data set. Okay. Once this processing will be finished, then only this node will be going to start. Okay. Yeah. Once this node will be yeah. Yeah. Once this node will finish its processing, then only the second node will be going to start processing. Once that is finished, the second node will going to process whenever it will going to finish its processing, then only the S3 will be going to start. That means no doubt I can able to store my data in a distributed environment in multiple nodes. But as there is dependency from one dataset to another dataset, I cannot able to achieve the parallel processing. Okay. We can achieve either distributed or parallel processing, but not both. Okay. What do you mean by parallel processing? Parallel processing means, suppose my data set altogether there is no dependency. I have there one is 5 GB, another one is 2 GB, another 3 GB. Okay. There is no dependency in between one to another. Whatever I have stored. Then what happened? All the nodes can process independently as there is no dependency to each another, one another. Okay. So I cannot the S2 does not need to or does not require to wait for the S1 machine to start, or S3 does not need to wait for the S2 machine or S2 node to finish its processing, because my data there is no dependency in between the data set that is stored in one machine to another machine, right? So either of the one situation I can able to handle, but not both in a distributed environment. Okay. Then the next is sharing mechanism is explicit in a distributed file system. Sharing mechanism is explicit. What do you mean by this? Let's say I am trying to explain you this stuff in a different way. Yeah. Suppose you are working in a project, let's say for the Cisco. Okay. And there are, suppose A is a team member, B also a part of this team, C is a part of this team, and D is a part of this team. Okay. So what happened? They are maintaining some network drive. Or shared drive. Or or you can say shared drive. Okay. The shared drive, let's say E. Sorry, E. Okay. So what happened? A is having the access, B is having the access, C is having the access to E drive. Okay. Suppose tomorrow another two members has joined the same team. Further, they are going to also work in the same project. Okay. Then what happened? They are, as soon as they are going to join this project, they are able to access this folder, access the network drive. They are able to access or they are not able to access. In your team, suppose 5 people were working in a particular project and everyone maintaining their folder, own workspace in a shared drive. The shared drive is required explicit permission, or that is a implicit permission. Explicit means someone, until unless not going to gives you permission to that network drive, you cannot access that folder, right? That means your project manager or manager, someone is going to give the access to this network drive, then only you are able to access that particular shared drive. Otherwise, you are not able to access, even though you are from the same project also, right? This is called explicit way of sharing. This type of sharing mechanism is known as explicit. Okay. So in this what happened? This node direct talks with this another node. S1 machine directs never speak with the S2 machine. Likewise, S2 machine never speak with the S3 machine. Everyone is do their job, report to the manager only. Okay. That means master node. Because in your project also you are also doing the same work. Whatever the task has been assigned to you explicitly, that task you are responsible for you are responsible to complete that task. No other team member you are going to complete that task, right? So you are only responsible to complete that piece of task and report back to your manager. In the same way, in a distributed environment also, each and every machine, they are responsible to process the data and report back to the master node. There won't be any kind of communication in between one machine to another machine. And moreover, whenever there is a